Hi everyone, I'm Abhinav Bharti, Solutions Architect at GoML, working in data and AI space. Over the last few years, I have worked on let's say 2025 plus POCs, taking them to MVP and then taking them to production V1 and then beyond. And like it is like across industries. If I talk about industry itself, it would be like healthcare, finance, BFSI domain, and then I worked in media and content generation, telecommunications domain. And somewhere around the journey of the POC is to know enterprise solutions and stop blaming the LLMs. Like when the solutions failed, what kept breaking was the architecture around them. Now, today I want to share 5 patterns where standard agentic architecture fails, not in theory, not in benchmark, but in production under real, conditions. Each one is a problem actually hit. Each one required rebuilding from the first principles. If you're building agentic systems or thinking about it, I think at least one of this is going to feel familiar, very familiar here. Okay. Now, I want to start with a statement that might be very uncomfortable for the AI adopters out there. Most agentic AI systems built today, right, will never see production. Not because the LLMs aren't good enough, not because the use cases aren't real, but because architecture underneath them was never designed to survive contact with reality. Like I've delivered like many use cases and taken a number of, all the way to the enterprise production systems. And the gap between these two worlds, right, POC and production, is where I've spent most of my time. See, today I'm going to show 5 patterns where the standard architecture breaks and what we built instead at GoML to make these systems actually work at scale. These are not, again, theoretical patterns. Every one single one of them came from hitting a wall in real engagement and having to rebuild from the first principles itself. Before want to go into the patterns, I want to be very clear about what I'm not talking about today. I'm not talking about the integration challenges. I'm not talking about the security, compliance, or audit gaps. I'm not talking about the use cases being too complex or the data not being ready. Those are real problems, I agree, but they are not, unsolved problems. They are the problems that are already solved. What I want to talk about is the failure mode that nobody names clearly. Agentic systems that have all these things figured out and still don't work in production because the architecture itself was not correct, or the architectural decision records were not properly, thought through. Now, a little context on where these patterns came from, like delivering across, multiple POCs, enterprise systems across industries. Again, this is not a portfolio. This is a pattern library. When you've seen the same class of failure happen across healthcare, telco, finance, media, you could stop calling it, just okay, LLMs aren't there. It might be a structural problem. The structural problem is this: the standard stack, right? Like you have the RAG systems in place, you have the React agents, you have the tool calling agents. These all are excellent for demonstrations, I would say at best. It produces impressive outputs in controlled conditions, but the moment you introduce real enterprise data, right, real users with unpredictable behavior and real scale requirements, it starts breaking in very specific ways. And there's the key insight I wanted to carry through this entire talk. The failure is almost never the LLM. The LLM is doing exactly what it's designed to do. The AI is, acting the way it's designed to do. The failure is the architecture around it, the topology of agents, the state management, the search strategy, the trust model, the knowledge layer. That's where we are here to talk about. No, so now moving on to the 5 structural patterns that I have, like I'll walk through each one, obviously, the problem it represents and the architectural approach we developed to solve it. Now comes first comes the pattern one, the orchestrator collapse. Okay, I had a problem statement where I had to, orchestrate a 52 agent for consumer level consumption, like okay. And what happens, and I'll talk about what happens when you have too many agents in a flat topology. Then I have a pattern two where we call it the search problem. When the complex planning for workflows need to backtrack intelligently. So backtracking problem from the classic problem solving, you can say, domain. And this one came from the automated, let's say, one of the use cases we had is automated site placements in telco. And one of the most nuanced planning problems I have worked on, to be pretty honest. Then comes the data to decision problem statements, how agentic data pipelines should surface and cite, not just an answer questions, and how the output should be changed based on who's consuming it. See, I can build a data decision platform which is very strict, right, in terms of like giving you the answers and all. But how it can be used across the enterprise, how we can democratize that knowledge was the real goal to achieve when we started building data root decision problem statements and solutions around them. Then comes the digital soul, like media and content generation has seen a lot of growth in getting the a digital twin of ourselves. And I'll talk about how we built a photorealistic identity consistent avatar video at 12.5 times lower GPU cost by deliberately breaking one of the most sacred laws in machine learning. We'll get to that. Then comes the Concilium, a multimodal clinical knowledge system in healthcare that automates what doctors call a concilium. The moment specialists convene on a complex case. Let's go. Let's have a look at the first pattern. And this one I wanted to feel before I explain it. So imagine like if you're an orchestrator, right? Your job is to look at an incoming message and decide which of the 52 agents should handle it. Not 5, not 10, 52. Now, research tells us, and our own experience and our production experience confirms that LLM routing accuracy degrades significantly beyond like 10 to 15 captions in context, right? Let's say yeah, happen to 15 agents in context. Now, the decision-making quality starts degrading there. The model starts hallucinating plausible sounding agent selections. Obviously, it routes the wrong specialists, and then this is one of that really breaks our experience, our user experience. It reroutes mid-conversation because one of the conversation points that the user gave at the prompt the user gave might very strictly belong to another agent. So in mid-conversations, it starts breaking, redirection starts fading. A user is a deep in a workflow agent A, the orchestrator decides agent B is a better fit, and suddenly the user's context is gone. Yeah, looking at the architecture, right, the solution has three interlocking parts. First, hierarchical grouping, domain-driven clusters of agents. The orchestrator never sees all 52. It sees group leaders. We compress the decision surface to something the LLM can actually reason about reliably. Second is the session lease pattern. Once the user-facing agent owns a conversation, one of the sub-agents, the orchestrator is locked out. Hard lock, we skip, like we created a shortcut to that agent in that moment. Hard lock, no mid-session rerouting, regardless of what the user input is here, right? Third, and this is the elegant part, the agent self-reports its own completion. It updates a state flag. The orchestrator only resumes normal routing on that explicit signal. It does not make the judgment call itself. The insight here is deeper than it looks, right? Like we didn't just organize the agents better, we distributed routing intelligence downward and use state to constrain when the orchestrator is even allowed to think. Here, so it saves me, prompt token costs. It saves me bad routing, that hallucination, mid-agent routing, and ruining the user experience. So pattern two, we have the search problem, and this one required me to throw away my first architecture completely. So the client is in a telco domain. The problem was the automated cell site placement. Like if I democratize the domain expertise knowledge here, it would be something like even if I'm putting up a shop, right? And I need to find out, okay, how how would the coverage for my shop would be like, will it be advantageous to me or not? So that decision, making goes a very, I can say, 20-step workflow for deciding on how to place network infrastructure with cell towers and network cell towers that we see, right? It's complex, nuanced, and very domain specific. The system kept backtracking. We go to step 15, propose a candidate site, and then discover it violated minimum distance requirements, for example, or the ROI wasn't there. Or, and this is the one that really stung, we realized that simply reconfiguring a neighbor cell or a neighbor tower would have solved the entire capacity problem without placing a new site at all. Now, if I look at the architecture itself of this one, again pointing it out, right, like the fundamental mistake was framing this as a workflow. It's not a workflow, it's a search problem. The moment I reframed it in that way, the architecture became very clear. We applied a search over the solution space. The key insight is the solution hierarchy. Parameter interventions are cheapest, then the existing asset optimization is medium cost, and the placement is expensive. You explore it in cost order, right? You don't jump to new site placement until cheaper options are formally exhausted. And formally exhausted is important here. Every rejected path produces a rejection artifact, a structured document of why this level couldn't have solved the problem. Right? When the system backtracks, it doesn't restart blindly. It navigates using its own prior reasoning. The third element that we had here was historical case heuristics. We have like decades of network planning data. The data feeds the heuristic function. The system doesn't start from search from the scratch. It starts from what worked in similar cases before. Backtracking isn't a failure mode here. It's mostly like a first class architectural feature here. Now moving on to the third pattern that we have, like in pattern three, we have data root decision. Here, this one came from a question that seems simple, but it isn't. Obviously, what does it actually means for engine to be useful with the data. Now this, right, data decisions like I have been asked a lot of times by like technical leaders across different industries and different clients themselves. Most people build data agents that answer questions like SQL generation, data fetch, returns results. Maybe a chart. That's not useful. That's a slightly more conversational, you can say, query tool. The real problem is in the enterprise data are the three things that nobody talks about, right? First is the schema hallucination. Enterprise databases have hundreds of tables, right? Inconsistent naming conventions, deprecated columns that still exist. Implicit business logic that was never documented, obviously. And LLM generating a SQL against raw schema will produce, syntactically valid queries that are semantically wrong. Now, here the main problem is. Now, what we did was our solution was to the LLM never sees the raw schema, right? It is a curated semantic layer, a business vocabulary that maps skills underneath into something the model can reason about reliably. The second is the wrong visual for the wrong person. Now, same query, same data, but a C-suite leader needs an interactive high charts dashboard they can explore, while a data scientist wants a matplotlib, data they can interrogate. We built a persona-aware rendering layer. Visual contracts follow the consumer, not the data itself. Configurable per user per role, like that's obvious. Now, the third problem I look at here is the streaming at scale, right? A TB scale, like terabytes of data scale in minutes cannot wait for a full scan before answering. We use progressive fidelity here. An instant answer from a materialized summary views at like t plus 0 second, sample based view at t plus 5 seconds, full comparison confirms at like t plus 30 seconds. If the estimate was wrong, the system revises and notifies. The agent doesn't wait for them. The data is always ready for the agent at multiple fidelity levels. This is one of the architecture designs that we solved using these principles. Now moving to the pattern 4, I'll call it the digital soul because the digital tuning in the media and the content generation domain is in high, you can say, demand right now. And I want to start this one with a number, right? 12.5 times cheaper. When I say 12.5 times cheaper, it is cheaper than the competitive, like leading industries, the leading competitors outside in the industry. Like the same broadcast quality, same identity consistency, and the same macro expressions, but 12.5 times cheaper and adoptable. How did we make it? So the client generated photorealistic avatar video at enterprise scale using open source model, right? They don't want to consume an API, obviously, due to the high cost. The problem with these models are that they're extraordinary, generating realistic humans, but just not the human that we want, like me, right? Our human face. Identity drifts from frame to frame and running off full inference on a GPU cluster for every video was financially unviable, right? Now, what we did here was we broke the one rule of machine learning, right? We overfitted. So overfitting is always bad in ML problems, right? If you have overfitted model, it's not good. But here we took an advantage of that. We deliberately overfit a LoRa adapter to one of the person's visual identity. Let's say facial geometry, micro expression patterns, skin texture, lightning response. We call this the digital soul, a portable identity container. So this is a portable container. I can run this container to on my friends or someone on my colleagues' identity. And crucially, we applied the identity lock before distillation, not the after. So general problem, like the general pattern that we follow is we do the distillation and then do the identity lock. That doesn't work, right? So the student model inherits the identity here. It's not a generic fast model. It's a persona specific fast model, right? So rule 2 broken, right? Sync audio after generation. We don't. The LM reads the script. So the agent sitting here, right? It reads the script the way a director reads it, not for the words, but for the human needs to communicate physically. It generates action tags, expression type, gaze direction, gesture, head pose, intensity. These become geometric conditions inputs to a generation. Auto sync is a constraint here, not a correction. Rule 3 that we broke here, right? Fix bad frames by regenerating. The identity consistency enforcer, right? What we call that stand-in mechanism, catches identity drift in a latent space before pixel decode. A correction. It's a correction, not a regeneration that we do here. Orders of magnitude are very cheaper here. The 12.5 doesn't come from one optimization. It comes from three computing, compounding layers. Smaller student model, it stepped distant inference instead of a 50 to get that same quality. Latent correction instead of regeneration. They multiply. That's where the 12.5 times come here. Okay, moving on next. We have the pattern 5, concilium, right? It's a healthcare specific problem statement. So, and I want to start with one sentence that reframes the entire problem. A patient, when I look at a patient, right? Like when we look at a patient is simultaneously an image, a time series, there a text document, a medical graph, and a genomic sequence. And again, this is not a data problem. This is a reasoning problem, right? And most healthcare AI systems treat it as a data problem. That's where we are like, looking at the problem statement itself wrong. They treat it as a data problem, rank clinical documents, it run the most relevant chunks. That gives us a very expensive search engine. It doesn't give me a clinical reasoning. Now, what we built here, right? What we built here is an automated concilium. In medicine, a concilium is when specialists, convene in a complex case. Neurology presents their findings, oncology presents theirs, cardiology weighs in, when a senior physician, synthesizes a recommendation. We automated this process here. The knowledge layer is a hybrid graph vector store on Neptune. So we have a graph vector store on Amazon Neptune here. Vector for semantic retrieval, graph for relational clinical reasoning, multi-hop queries like drug contra indicated that drug B patient with condition C who carry biomarker D. Here, no flat vector store can handle that, but graph does. Retrieval is bipartite, two phases. First, we build a full model fingerprint for the patient across all data types. Then we search for similar patients, not only in a single modality, but in the combination, like imaging pattern crossed with lab trajectory crossed with demographic profile. That's just an example. The rare case that looks unusual in one modality may have clear, precedent across three. Every output passes three validation dimensions here, not just one. Provenance, which records support this claim. Integrity, does the logical chain hold? Robustness, does the recommendation survive if we remove one modality? The third one, the robustness, is what makes this clinically defensible. A conclusion that collapses when you remove a single data source is a conclusion you cannot defend in a clinical or legal context. This is the difference between AI that assists clinicals and AI that thinks clinically. That's what I would say here. Okay, moving on to the next. So what's the thread that connects all five of these, right? Topology is architecture. How you arrange agents matter more than what agents you pick. Flat breaks at scale. Hierarchy with intelligent state management rewards gives. Complex problems are search problems. The instinct to build a workflow is almost always wrong for anything with more than a handful of decision points, right? Cost order search with pruning and memoization is the right abstraction. Memoization, again, going back to our classical concepts. Output is a consumer aware. The same data should have produced different responses for different people. Building one output format for everyone is leaving value on the table. We are not fully utilizing the solution that we were, out to build. Compression prevents intent. When you, sequence it correctly, log the entity and direction first, compression second, not the other way around. And explainability is the product, especially in regulated domains like in healthcare, BFSI. A correct answer you cannot defend is not a correct answer. Audibility, right? Auditability or provenance or robustness, these are features, not like we don't put it in our thoughts. LLM is really the bottleneck, that's what I would say. And like as mentioned again and again, I know stop trying to fit one solution for all the problems. I'll say that again because it runs counter to where most teams spend their energy. The LLM is really the bottleneck. The architecture around it always is. That's the relation from solving multiple POCs and take into enterprise production systems. Thank you.